All right, welcome to Doozer Shop. We're still continuing making parts for the Colchester 17. I took the liberty of sorting out the details, and I'll show you. Hey, yeah, look at that. That's like one of those MC Escher parts. Where it's the part, impossible part. So this side, there's an isometric right there. That slot allows this cube to go on the cross rail that's going to support two of these. I need to make another one. This will support the that little rocker box for the power feed. It looks like a perfect isometric SolidWorks part. So the bottom slot is to actually mount it to the rail, and I'm going to have a flat cap that's going to bolt on to those 1/4 20 screw holes. And the actual dog in the rocker box will slide in here. So the dog, when the box locks into gear, the little finger dog will, you slide the box into engagement and it locks it in sideways. Click it out, move it over, lock it in the other one, pop it up, move it over, lock it in this one. So that's how that's going to work. So that's why, the difference in orientation. One's for the actual mounting bar, and the other one's for the actual dog that slides in and out through an arc when the rocker box is engaged for the power feed. So this is that guy. We're starting with a piece of solid stock. This was bar sheared off the end. You can see the nasty end shear, but what I'm gonna do, this was bandsaw cut on the top side. I'm gonna face this off in the middle, bandsaw cut the nasty side, because this is sort of a development piece, and I got the length now, the depth of my slots and the width of my slots, so this one should go easier. So let me show you setting this up in the mill. Because you just don't throw it in, you guys know, you don't throw it in the vise, you got to indicate it and make sure it's square. You could use a square. So it's in the old 5-inch vise here. I'm going to hold it off the bottom a little bit. And I'm going to be tapping this around. So you can see that. Oh, maybe you can't. Either way. So, get my dial indicator. I gotta move the table down. I'll indicate off this side so you guys can see what the indicator's doing. So I've got lots of dial indicators. I started out with a Starrett, I think it's a 711, last word. And I've got, Brown and Sharp, the Inner Rapids. I've got Alina, Compact. I think Compact and Alina are the same thing. But for a lot of instances, don't laugh at me. I find that the Starrett last word gets into a lot of places that many indicators will not. I've got the 3/16 shank on the last word. It comes with a 5/32 shank. I don't think any collets are 5/32. I ended up using just the 3/16 shank. All right, so I'm positioning this and about 0. Let me fine tune it with the table. You don't have to in this case, but you should get it in the center of axis of rotation where it seeks the high point. Right, like that. See how it comes up, stops, reverses, and comes down? It's a good idea to keep it at the high point, okay? Now, I'm going to be sticking my big fat head in here because it's hard to see. Me back off the table and zero it because all the obsessive compulsive disorder people in the world like to see a zero on the indicator. So I just stuck it in there by hand. Alright, so I'm going to use the quill, and this adds the tram error, if any, in the head. So the final indicating I will be doing with the knee. And my quill stop is set. Get that out of the way. I need a quick nut. They sell those. Alright, so there's zero. You can see that. And it comes up to the top, and you got 5 to the high side. So let me try and tap. I thought that I could do it with my chip brush. So there's 2.5. Alright, so what I was doing there, I was seeing where it was pivoting. If it was pivoting at the bottom, I could take the full 5. I didn't know sometimes it would pivot in the middle. Let's see where that goes. Let me take just a scotch more. Alright, maybe that was too far, I don't know. Maybe it was a scotch too much. Alright, you'll see it runs out a little on the bottom because the bar was parted off and the surface is not truly flat. So like I said, that's tramming it, indicating it with the quill. And if the head is off, you really want to tram it with the knee because the knee is part of the machine base. So let's run the knee up and down and see where she goes. She's staying pretty zeroed now. And I think I got the head trammed in pretty well, but this is just kind of to show you folks. Oh yeah, it's staying right at 0. Now this didn't take that long. And then, like I said, I just set it in the vise. It's not setting on the bottom of the vise. It's kind of in midair. And then it does start to deviate at the bottom. So I'm happy with that. So I'm going to snug up the vise. Alright, so that's snug. Let me run it down. And like I say, that needle's pretty good. I'm not chasing tenths here, folks. I could, but I'd probably get a different indicator. Alright, I'm satisfied with that. We're within half a thou, maybe less. So my vise is tight, my piece is in there. I'm going to steal my indicator out and put in an end mill. Okay, I'm going to set the indicator over here. Take the collet out. So this is a 3/16 collet. Let me roll it around, put it away. Grab my 3/8 collet. And let me grab the 3/8 end mill that I had been using for most of this stuff. And put it up and tighten it up. I'm going to move this piece so it doesn't get full of chips, because I need to measure it perhaps. Tighten the drawbar. Alright, release the drawbar lock. I guess I've taken light cuts I can mill with the quill down. You should always tend to err on the side of raising, have the minimum amount of extension. I'm going to kind of look and see where the low spot is. The low spot might be in this corner, and I'm going to touch up on the low spot. Check the lock, we're good. Here we go. Alright, I'm pretty good with that. I'd say decent surface finish. Alright, I guess I'm happy with that. Alright, so I'm going to release the quill. So I am going to take this block out of the mill, cut it a little bit oversized, maybe a 1/16 oversize on the bandsaw, and square this up again. So I'm going to do that. I'll be right back and show you guys the progress. Alright, I checked this. This is really good with the square, and what I'm going to do, I'm not going to indicate anymore. I'm going to just use the parallels and pop it in there, and I'm going to do a minimal cleanup pass, and I'm going to possibly take it out and measure it. So I got it in there. Feeling my parallels. Alright, both my parallels are tight, and I can't get any perceivable movement in the parallels. So now I'm going to give it a final tightening on the vise. I'm going to feel them again. Oh, see that one got loose. This one's tight. Alright, that's back tight. That back one's tight, the front one's tight. So we're reasonably flat. If this parallel, wouldn't tighten up and the back one would be tight, that means something's, out of whack. But anyways, alright, so that's in there. I can see my scribe line, you guys probably can't, so I kind of know where the dead zone is, if I go too far and blow my part. So I may be able to measure this in the milling machine. I may have to take it out and measure it. Let me get close, and I'll bring the knee up. And here we go. You can still see some bandsaw mark. Come on up with the knee. I'm really not cutting much. Okay. Alright. Now, I can still see my line. I wonder if I can get the calappers in there. Oh yeah. I can definitely measure. So let me set a 0 on these. Get my piece. Alright, so what I do is I measure, squeeze them, 1.765 and a half. So if I like that, oops, stay on there, Doozer. Oop, oh yeah, there you go, that's why. Alright, 1.765, I'm going to 0 it. Forgive the knuckle shuffle. So that's my target dimension on this dude here. So it looks like I have to take off. I'm squeezing the outside, I'm sorry, the inside jaws. Maybe I can squeeze the outside jaws. I can, I get the same reading. So it looks like 36.5 thousandths. Now it says 37, let's see. I'm looking at 37 thousandths. Alright, this is how we do it, folks. So I gotta take off 37. So I'm gonna take off 30, and then I'm gonna check it. So let me do 15. I could just do 30. Alright, let me see what 15, I forget what I took the first time, it doesn't matter. So there's 15. Alright, that was 15, let me go another 15 for a total of 30, and I gotta do 37. Let me go down, I overshot it, right at 30. 30. Alright, here we go. Alright. So you gotta make sure when you measure there's no burrs. Sometimes you gotta run a file across it. Alright. If the world is going according to plan, I should have 7 thousandths or so. My calipers are getting slightly magnetic. I don't like that atoll. I'm looking at 8 thou. And this is not a hypercritical measurement, the overall height. Eight. Alright. I'll take 8. 30, so 35, 6, 7. Alright, 7.5. Let's live. Here we go. Okay. Pretty neat. Oh yeah, love it. Alright, now I'm going to measure. Make sure I didn't blow my number. Measure, that's French. Man, I gotta degauss these or something. It's just chip sticking. Alright. Two thou. Alright. 2 thou. Alright. All right, I'll make another quick pass and I'll bring it back. Okay guys, I got the piece with the edges cleaned off, because the next step is to find the center and make the slot. So, if you remember last time, my edge finding, I kept resetting the wrong axis. I don't know why. We're going to try and do a good job on this one. Approximately 1,000 RPM. This is the y-axis. Alright, that kicked. Try and repeat it. Alright, that repeats. Let me go to the other side. Alright, 5, 7, 3. Five, 7, 3. Alright. 1.573 divided by 2. 7, 8, 6 and a half. Seven, 8. Alright. So that's the center that way. Now, pick up this direction, which is the X. Alright, that kicked, reset the X, try it again, sneak up on it. Kicked, number's the same. Six, 9, 7. 6, 9, 7. 1.697 divided by 2. 848 and a half. Five, 6, 7, 8. Come on now, 7, 8. Alright, close enough. Now we're really slotting this direction, so it doesn't matter for centering, but alright. And just so you folks know, we're going to do this slot first, where I'm going to have the tapped holes. So, put my end mill in, tighten up the drawbar. I don't want to slip. Alright, the drawbar is tight, not too tight, because there are more taper collets. Alright, so that, I should probably, you know what, I am going to put it at the top and crank in my number, my Z number, up from the knee, because I don't want this thing pushing. And I gotta see how far I got to go down. Oh, I know what it is. It's 9.95. Alright. So we're going to touch off and we're going to 0 and start cutting. That quill is locked. Alright. Sneak up on it and get my 0 on my knee wheel. Yeah, 0.95 is the depth. Alright. Alright, it's barely touching. Alright, so I reset the dial to like half a thou. Alright, so I'm going to crank in 100, 50, 100. Alright, I know you guys can't see that because the vibration's too much. Let me figure out something different. Let's see here. Alright, I got the camera isolated somewhere better for you guys to see. Alright, so first cut looks good. Make sure the y-axis is locked, crank it another 100. And here we go. Alright, final pass here. I'm at 900, I just cranked in 50, and I measured, make sure I'm not going to go past it. And I'm going to take the last pass here on the depth of this pocket. I'm to full depth, and now what I'm going to start doing is widening out the pocket by offsetting the end mill in the Y direction, positive and negative, to try and widen that slot. Let's see here. I could conventional cut or I could climb cut. Let me do some 10 thou. Let me cut conventional 10 thou here. Let's see what the finish looks like. I think I gotta go to like 60 each side. Or maybe it's 88, I forget. We'll figure it out. No, it's a 3/8 cutter, and I gotta make a 1/2 inch slot. So I gotta go a 16th or 60 thou either way. Go 30 the other way. I have a feeling it's going to like climb cutting better. squeaking. My finish is okay. It's drawn a burr. Yeah, I don't like that. Hope I wasn't. I don't know. Let me climb. Let me go to the 10th thou and climb. I'm at 30 thou. Let me go 40. It sounded better. Maybe my cutter's getting all just dull and ragged. 40. Yeah, I think we're just going to climb cut it because the finish looks awesome. So now, climb cutting, you have to understand, it wants to pull the work into the cutter. So if there's any lash in your screw, that lash is gonna, if you're pushing the table, it's gonna pull the table and suck the table forward by whatever lash is in your bronze nut. It leaves a nice finish when you climb cut, nicer than conventional cutting. You gotta be careful, like I said, of the pulling of the table. It wants to climb. And the difference is conventional milling, the chip actually, you know, the cut starts out and the chip size is small, and when the chip is fully formed and made, the chip is very thick than conventional. Climb cutting is the opposite. The chip, the bite that the cutter takes is thick. Well, the chip is thick and it's a bigger bite, and then it dwindles off and the chip gets thinner. So you can actually probably tell by the chips if it's conventional or what. I'm going to check on the caliper here. Sanity check. How wide my slot is. I'm at 7/16. 438. Let me keep going here. I was at 40. Let me do 50 thou. 50 thou climb cut. 49, 50, lock, cut. Now let me go 50 the other way. Lock, cut. Alright, I'm going to measure again because I'm 20 thou away. I'm gonna zero my calipers on 1/2 inch. 500. That way it tells me how much I need to take off, and it should say about 20. Alright, I'm at 500. Now let me take my measurement. And I know you gotta be real careful because if there's a burr, you're gonna get a bogus number. 35 thou. So if I go to 60, it'll be 10 and 10, 1/8 side, it'll be 20 thou. Let me take another 10 each side for a total of 20. Loosen the Y, crank opposite to 60. Alright, 60. All right. Looks like 1 thou tight. Let me get my mating piece. So this bar is the mating piece. Let me suck this swarf out of here and come back. All right, folks, got you back here. I got the piece lightly dressed with a file, and the actual mating bar that slides in, you know, fits well. And so now a cap's got to go on there. So what I got to do is I got to make some threaded tapped holes in here. And the deal is, right where it's at, and I learned this from doing the last one, that drill is exactly halfway in between, you know, this feature, this top of that wall, I guess you'd call it. And that happens to be 0.469 inches from the center point of this. 469 up and 469 over. So it's a square, even though this block is a little rectangular. It's got a square pattern. And point, you might see it right here on the vise. I wrote it on the last block I made. That's a 32nd fraction. I forget which one. I looked it up on the chart. But I always design in fractions to respect the inch, the imperial system of measurement. So I'm going to drill and tap 4 holes. Right now I got my center drill, and here we go. Okay. So now what I do is I come down and I'll just put the point in. Here, let me show you. The point is halfway penetrated, and I set the quill lock. Now the point is fully penetrated, and I set the quill lock again. What that does is that lets me dwell for a second in the cutting flutes of the drill bit. It gives them time to cut evenly around and self-centralize. You kind of do this when you're doing a jig boring work. You be very careful not to let the tool wander off course. Yeah, so that's what I do. And then I'll continue just drilling it until the countersink part just starts. And right when I hit the countersink, I'll stop it, lock the quill, let it dwell for a second, and it might like squeal for just a smidge, and then retract. Again, centralizing that center bit. I just letting it dwell while the cutting force is diminish. Okay, 0.469, 0.4, 3, 4, 5, 6, 7, 8, 9. And let me lock 0.469, 0.469, both in the minus. release. All right. Like I say, it's the little details in machine work that, you know, that make the deal. All right, so now I gotta drill these to 201 because that's the size for a quarter 20 tap. Now, where did I put them? Here they are. So what this is a 201 drill, a number 7 drill, and I ground the shank down to 3/16 so it fits in a 3/16 collet. So how awesome is that? Wouldn't it be fabulous if they actually sold drill bit sets in fractional collet sizes? How nice would that be? I mean, Silver and Deming bits all have a 1/2-inch shank, so you know, that's cool. So that was a 1/4 inch center drill, and this is a 3/16 collet. Put my 3/16 shank number 7 drill in there. Now, for this mill, I've got a set of screw machine length bits, and you know what that is they're just shorter drill bits. And it's nice that you don't have to wind down the table so much and yada yada. Okay, 0.469. 469. Lock the table. Okay, I'm going to set my depth here. I'm going to go. Now I'm going to set. Yeah, you can't see it, but I'm going to set the quill stop to 3/4 of an inch depth. I'm going to use my caliper and set it. Alright, close. Alright. I like that. Let me put some Earl on it. Alright. Alright, I drilled 2 holes. I'm going to drill the others. I'll put you on pause and bring you back. Alright folks, got you back. We're going to tap these holes now. Got them all drilled out to 201. Let's see what we can do. I went about 1/2 inch or 5/8. I might hand tap them to the bottom. 4, 6, 9. Come on, 7, 8. All right. So these are spiral flute taps. Spiral flute taps withdraw the chips from a blind hole. Spiral point taps shoot the chips forward. I almost said shoot the chooch. Shoot the chips forward if you have an open hole or a through hole. 4, 6, 8. It helps me to say this aloud so I don't screw it up. My numbers, that is. This is like a $15 tap. Once I learned, like, good taps are just, you know, the way to go. Hardware store taps, you know, hand taps. I mean, hand taps will get you by, but you can't put them in a machine. 6, 9, 4, 4, 6, 9, 8, 5, 9. You can't put them in a machine and expect it to do, you know, all the way down like I'm doing here. Start it, let go. And with a variable frequency drive, you know, it makes it so nice. Because I'm going, that's 13 hertz, you know, I mean that's just so awesome. All right, let me clean this up and I'll show you the next thing. All right, let me zoom you in here, folks. All right, this is where we're at. So far, that one's done. I still have to slot that one. But you can see the slot we just made, you know, it's going to fit this bar, okay? So what's going to happen is it just fits within a thou or so of clearance. It's nice. I'm going to make a cap for that one and that one. It's going to have 4 screws. To tighten it, you may be able to see it's the bar is proud by 50 thousandths. Okay? And what's going to go in there is that tang, that little dog that sticks out, the tab from the rocker box in the Colchester lathe. So that's where we're at. Let me bring you back. We're going to set this one up in the mill, and we got to we got to mill the slot this way on the bottom, and then yeah. So let me get that set up in the mill, and I will bring you back.